Nikola Tesla once said, "If you only knew the magnificence of the 3, 6, and 9, then you would have the key to the universe." But what did he mean by that, and why these numbers? From ancient structures to nature and spirituality, they seem to appear everywhere. In this video, we'll explore the patterns, history, and mysteries behind 3, 6, and 9 to see whether there's truly something special about these numbers, or if it's all just a cosmic coincidence wrapped in conspiracy. Let's find out. Let's begin by looking at time measurement. In one day, there are 24 hours. 24 is a multiple of 3 and 6. There are 1,440 minutes in a day, which is a multiple of 3, 6, and 9. There's 86,400 seconds in one day, which is also a multiple of 3, 6, and 9. Notice too how every number that is a multiple of 9 has a digital root of 9 as well. So what is a digital root? The digital root of a number is the result of repeatedly summing the digits of a number until you're left with a single digit. So in the case of 1,440, we add 1 plus 4 plus 4 plus 0 to get 9, and with 86,400, we add 8 plus 6 plus 4 plus 0 to get 18, and then we add 1 plus 8 to get 9 again. In half a day, there are 12 hours. 12 is a multiple of 3 and 6. There's 720 minutes in half a day, which is a multiple of 3, 6, and 9. There's 43,200 seconds in half a day, which is also a multiple of 3, 6, and 9. Now keep this number 43,200 in your mind, as it will come up in some strange places later on. In 1 week, there are 168 hours, 10,080 minutes, and 604,800 seconds. Again, we see similar patterns of these numbers being multiples of 3, 6, and 9. In one 30-day month, there are 720 hours, 43,200 minutes, and 2,592,000 seconds. Notice how since all of these numbers are multiples of 9, they have a digital root of 9 as well. In 1 year, there are 8,760 hours, 525,600 minutes, 31,536,000 seconds, and 12 months. Again, we see similar patterns within these numbers of being multiples of 3, 6, or 9. Next up, let's look at the measurement of some polygons. In a regular triangle, one angle is equal to 60 degrees. This number is a multiple of 3 and 6. Now the sum of all interior angles of any triangle is 180 degrees, and this number is a multiple of 3, 6, and 9. Notice how since 180 is a multiple of 9, its digital root is still equal to 9. In a square, one angle is equal to 90 degrees, and the sum of all interior angles of any quadrilateral is 360 degrees. 360 is a multiple of 3, 6, and 9 again. In a regular pentagon, one angle measures 108 degrees, and the sum of all angles measures 540 degrees. Notice too how the sum of all the angles in any polygon will always be a multiple of 3, 6, and 9. In a regular hexagon, one angle measures 120 degrees, and the sum measures 720 degrees. In a regular heptagon, one angle is about 129 degrees, and the sum of all angles is 900 degrees. In a regular octagon, one angle measures 135 degrees, whereas all angles sum to 1080 degrees. In a nonagon, one angle measures 140 degrees, whereas the sum is equal to 1260 degrees. In a decagon, one angle measures 144 degrees, whereas the sum is equal to 1440 degrees. Again, this sum remains a multiple of 3, 6, and 9, just like the sum of the interior angles of any polygon. Now let's look at the measurement of some circles. A full circle equals 360 degrees. This number is a multiple of 3, 6, and 9. Again, because 360 is a multiple of 9, its digital root is equal to 9 as well. A half circle has 180 degrees. This number is a multiple of 3, 6, and 9 again. A quarter circle equals 90 degrees, another multiple of 3, 6, and 9. An eighth circle measures 45 degrees, a multiple of 3 and 9. 1/16 of a circle measures 22.5 degrees, which has a digital root of 9. 1/32 of a circle measures 11.25 degrees, which also has a digital root of 9. 1/64 of a circle measures 5.625 degrees, which also has a digital root of 9. Even 1/128 of a circle measures 2.8125 degrees, which also has a digital root of 9. This process of cutting a circle in half repeatedly will always result in a digital root of 9, 14 times total, including the number of degrees in 1/16,384th of a circle. Now let's look at space measurement. In one dimension, we have 1 foot is equal to 12 inches, 1 yard is equal to 3 feet, 1 yard is also equal to 36 inches, and 1 mile is equal to 5,280 feet. As you can see, all of these numbers are multiples of 3, most of them are multiples of 6, and one of them is a multiple of 9. In 2 dimensions, we have 1 square foot is equal to 144 square inches, 1 square yard is equal to 9 square feet, 1 square yard is equal to 1,296 square inches, and 1 acre is equal to 43,560 square feet. As you can see, all of these are multiples of 3 and 9, and most of them are multiples of 6. In 3 dimensions, we have 1 cubic foot is equal to 1,728 cubic inches, 1 cubic yard is equal to 27 cubic feet, and 1 cubic yard is equal to 46,656 cubic inches. Again, all of these numbers are multiples of 3 and 9, and most are multiples of 6. Now let's look at some Earth and Moon connections. Starting with the Earth, its radius to the nearest whole number is 3,963 miles. This number is a multiple of 3 and has a digital root of 3. Its diameter to the nearest whole number is 7,926 miles, which is a multiple of both 3 and 6, and has a digital root of 6. Its orbital period is 365.25 days, which has a digital root of 3. Earth's precession moves 1 degree every 72 years, a multiple of 3, 6, and 9. Again, since it's a multiple of 9, it has a digital root of 9, meaning a full precession takes 25,920 years, another multiple of 3, 6, and 9. Earth's axis is currently tilted at 23.4 degrees, which has a digital root of 9. Now, for further clarification, Earth's precession is when the Earth slowly wobbles as it spins like a spinning top. It moves 1 degree every 72 days in this circle, meaning 1 full circle or precession will take 25,920 years. Whereas its axis is tilted at 23.4 degrees from a line that is perpendicular to its orbit around the Sun. We also have the Schumann resonance, which is often referred to as Earth's heartbeat. This is the set of naturally occurring electromagnetic waves that resonate between Earth's surface and the ionosphere. Its fundamental and most common frequency is 7.83 Hz. This has a digital root of 9. Now looking at the Moon, we have its radius to the nearest whole number is 1,080 miles, which is a multiple of 3, 6, and 9. The Moon also orbits the Earth about every 27 days, another multiple of both 3 and 9. Now let's look at how these numbers connect to the Great Pyramid of Giza. First off, there are 3 main pyramids. One side of the base of the Great Pyramid of Giza is about 756 feet, which is a multiple of 3, 6, and 9, making the perimeter of the base about 3,024 feet, another multiple of 3, 6, and 9. Remember how in a half a day there was 43,200 seconds, and in one 30-day month there was 43,200 minutes, this number being a multiple of 3, 6, and 9? Well, if we take the perimeter of the base of the Great Pyramid, 3,024 feet, we convert this into miles, and we multiply that by 43,200, we get about 24,742 miles. Now if we look at Earth's equatorial circumference, the distance around the equator, since we have to remember Earth is wider at the equator than it is at the poles due to its rotation, we get about 24,901 miles. This means that the perimeter of the base of the pyramid times 43,200 gets us a number very close to the equatorial circumference of the Earth, with only about a 0.6% margin of error. Now if we take the original height of the pyramid, which is about 481 feet, again, we convert this to miles and we multiply this by 43,200, we get about 3,935 miles. Earth's polar radius, so the distance from the center of the Earth to either one of its poles, is about 3,950 miles. This means that the original height of the pyramid times 43,200 gets us a number very close to the polar radius of the Earth with only about 0.4% error. So this leads us to ask the question, is it possible that the Great Pyramid of Giza is a scale model of the Earth at a ratio of 1 to 43,200? Now let's look at the significance of the number 108. 108 is a significant number in Hinduism, Buddhism, and Sikhism, which we'll explain more in the next section. 108 is a multiple of 3, 6, and 9. As we mentioned earlier, since it is a multiple of 9, it has a digital root of 9 as well. Now if we look at the Sun's diameter, which is about 865,000 miles, and we multiply this by 108, we get 93,420,000. The average distance from the Earth to the Sun is 93 million miles. This gives us a difference of 0.5%. However, we do have to take these numbers with a grain of salt as the sun's diameter changes due to its solar activity, and it also depends on how you measure it since the sun does not have a solid edge to it. Similarly, if we take the moon's diameter, which is about 2,159 miles, and we also multiply this by 108, we get 233,172. The average distance from the moon to the Earth is a little more at 238,855 miles, but that is still only a 2% difference. So to summarize, the diameter of the sun times 108 is about our distance to the sun, and the diameter of the moon times 108 is also about our distance to the moon. Now let's go over the significance of these numbers in spiritual and religious contexts. The number 108 holds spiritual significance in Hinduism, Buddhism, and Sikhism, as mentioned earlier. It's often associated with wholeness, infinity, and the completion of a spiritual cycle. In each tradition, 108 is used in various practices, including mantra chanting, meditation, and the creation of sacred objects. When referring to frequencies, we have 432 Hz, a multiple of 3, 6, and 9, and a number that we have seen pop up repeatedly throughout this video, which is said to be a more natural resonance and sounds more harmonious and calm compared to the industry standard of 440 Hz, a number that is not a multiple of 3, 6, or 9. We also have 963 Hz, a multiple of 3 and 9, which is often referred to as the God frequency by some and is said to promote spiritual connections and activate the pineal gland. However, neither of these are scientifically proven. Here's a chart of how the numbers 3, 6, and 9 are significant in the religions of Christianity, Judaism, and Islam. The second chart also shows how the numbers 3, 6, and 9 are significant in Buddhism, Hinduism, and Sikhism. Now let's go over mathematical anomalies involving 3, 6, and 9. To start off, 9 is the only digit where adding or subtracting it from a number does not change its digital root. For example, 34 has a digital root of 7. 34 plus 9 is 43, and 34 minus 9 is 25. Both of these have a digital root of 7. When it comes to doubling numbers, any number when doubled repeatedly and reduced to a single digit falls into a 6-number cycle, except for 3, 6, or 9, which follow their own unique path. As you can see, when we double 1 and take its digital root, we have 1, 2, 4, 8, 7, 5, and then these numbers repeat. What's also interesting is we never see 3, 6, or 9 in this pattern as well. With 2, we have the same thing just starting at 2. 4 and 5 follow the same pattern as 1 and 2 just starting with their respective numbers. However, with 3, it just repeats 3 and 6 over and over again. Starting with 6 and doubling it, it repeats 6 and 3 over and over just like it did with 3, but starting with 6 instead. 7 and 8 follow the same 6-digit cycle as the previous numbers except for 3 and 6, just starting with their respective numbers. And starting with 9, it just repeats 9 over and over again, which is expected as all of these numbers will be multiples of 9, and any number that is a multiple of 9 has a digital root of 9, which is another anomaly in itself. Numbers with the same digital root follow the same pattern, so for example, 34 has a digital root of 7, it will follow the same pattern as 7. When it comes to skip counting, any number when skip counted repeatedly and reduced to a single digit falls into a cycle containing all 9 digits, except for 3, 6, or 9, which follow their own unique path again. As you can see, when we skip count by 1 and take its digital root, we just cycle through all 9 digits. And although the order is different for 2, 4, and 5, we still cycle through all 9 digits. However, when we skip count by 3, we just repeat 3, 6, and 9 over and over. When skip counting by 6, we just repeat 6, 3, and 9 over and over, similar to how we did with 3. And when skip counting by 7 or 8, although the order is different, we just cycle through all 9 digits repeatedly in a pattern as well. When skip counting by 9, again we just repeat 9 over and over, which is to be expected of as all of these numbers will be multiples of 9. Likewise, as mentioned earlier, numbers with the same digital root follow the same pattern. Given everything we've seen so far, it's time to ask the big question. Are these patterns truly sacred, or are we just seeing what we want to see through selective perception? First off, One explanation for why many of these numbers are multiples of 3, 6, and 9 is that when you multiply a multiple of a number by any other number, it stays a multiple of the original number. This could give some explanation of what we saw in the first section of time measurement. For example, since the number of hours in one day, 24, is already a multiple of 3 and 6, the number of hours in 1 week will remain a multiple of 3 and 6 since we just multiplied 24 by 7. The number of hours in one 30-day month will also remain a multiple of 3 and 6 since we just multiplied 24 by 30. However, this number, 720, turns out to be a multiple of 9. This could also give some explanation to what we saw in the section of space measurement. Since 1 yard equals 36 inches, a number that is already a multiple of 3, 6, and 9, 1 square yard, or 36 times 36, as well as 1 cubic yard, or 36 times 36 times 36, will both remain a multiple of 3, 6, and 9. This could also explain why all the interior angles of any polygon are multiples of 3, 6, and 9 as well, as we saw in the section of polygon measurement. The formula defined the sum of the interior angles in any polygon is n minus 2 in parentheses times 180, where n equals the number of sides in that polygon. This formula is based off of the number of triangles you can draw inside a polygon. You can always draw 2 fewer triangles than the number of sides in a polygon. For example, if a shape has 5 sides, it is made up of 3 triangles, and if a shape has 6 sides, it is made up of 4 triangles. And since the sum of all angles in a triangle is 180, which is already a multiple of 3, 6, and 9, the sum of all interior angles of any polygon must also be a multiple of 3, 6, and 9. Now you might be wondering, wait, can't you draw 6 triangles in a hexagon like this? And you are absolutely right. But these angles of the triangles here don't make up the angles of the hexagon. So although this does explain why the sum of all angles in any polygon is a multiple of 3, 6, and 9, it is still fascinating how all polygons can be made up of triangles, 3-sided shapes where the sum of their angles is a multiple of 3, 6, and 9, showing how these numbers do have some significant properties. Additionally, triangles are the strongest shape, which is why we almost always see them in bridges somewhere, further contributing to the sacredness of these numbers. Another thing to recognize is that many of these sacred numbers have many other divisors other than 3, 6, or 9. For example, 108 has 12 divisors total and 432 has 20. However, despite this, both 108 and 432 do have a digital root of 9. Additionally, there are other sacred numbers in religion that are not related to 3, 6, or 9. For example, 7. In Christianity, there are 7 sacraments. In Judaism, the menorah has 7 branches. In Islam, there are 7 heavens, and in Hinduism, there are 7 chakras. Another example of potential selective reasoning is how there are plenty of examples within the themes mentioned that don't relate to 3, 6, or 9. For example, how 1 mile equals 1,760 yards, or how 1 acre equals 4,840 square yards. Neither of these are multiples of 3, 6, or 9. I mentioned earlier how the moon's radius to the nearest whole number is 1,080 miles, which is a multiple of 3, 6, and 9. But its diameter to the nearest whole number is 2,159 miles, which is not a multiple of either of those. Some of these also depend on how you round them too. For example, if you look at a year as 365 days, this is not a multiple of 3, 6, or 9. But as 365.25 days, it now has a digital root of 3. Another thing to keep in mind is that some data values vary from source to source. For example, some websites say the Earth's tilt is at 23.5 degrees, which does not connect well to these numbers, whereas others say it's 23.4 degrees, which has a digital root of 9. I went with 23.4 because that's what NASA says on their website. Some sources claim the sun has a diameter of 864,000 miles, which is a multiple of 3, 6, and 9, but most claim it is closer to 865,000 miles, which is why I didn't mention it earlier. And while there's no strong evidence that the Great Pyramid was built as a scale model of Earth at a 1 to 43,200 ratio, at least not according to mainstream scholars, the numerical relationship is still intriguing and, to me, hard to dismiss. Another thing you might have wondered is, okay, but multiples of 3 are just 1 and 3, multiples of 6 are 1 and 6, and multiples of 9 are 1 and 9. So of course they are common and we can find many examples of numbers that fit this criteria. But when it comes to measurements, humans tend to prefer measurements ending in 0 or 5. This can be seen with pricings, estimation, or many other examples, especially when you consider how we use a base 10 number system, which the vast majority of researchers, anthropologists, and historians believe originate from us having 10 fingers. Given Given this, these patterns should appear much less often. Yes, multiples of 3 are 1 in 3, but multiples of 3 ending in a 0 are much less common and only 1 in 30, and multiples of 3 ending in 0 or 5 become 1 in 15. Although multiples of 6 are common too, 1 in 6, multiples of 6 ending in 0 are 1 in 60, and since multiples of 6 cannot end in a 5 due to them all being even numbers, multiples of 6 ending in a 0 or 5 remain 1 in 60. Although multiples of 9 are 1 in 9, multiples of 9 ending in a 0 are very unlikely or 1 in 90, and multiples of 9 ending in a 0 or 5 are 1 in 45. So these patterns should appear much less often than they do, which may explain why we rarely see them in the metric system. Speaking of the metric system, you might have noticed that I didn't even mention them once yet. Why? To better understand why we don't see patterns of 3, 6, and 9 as often in the metric system, we need to dive into the history of the metric system and how it was created. The metric system was developed and officially adopted by France in 1795. The imperial units such as inches or feet were created long before this and were even used during ancient times, but they would vary from town to town. The metric system was created to bring consistency, simplicity, and universality to measurements. It was based on nature. For example, the meter was originally defined in the 1790s as 1/10,000,000th of the distance from the North Pole to the equator measured along the Earth's meridian or line of longitude that passes through Paris. But this was difficult to measure precisely and the measurement was slightly off, so the definition has since changed and today, the meter is instead defined by the speed of light. The metric system was also based on decimals or powers of 10. For example, 1 meter equals 100 centimeters, which is 10 squared. 1 liter equals 1000 milliliters, which is 10 to the third. Napoleon's armies introduced it into the territories they conquered, helping to spread it across much of Europe. So then, how were the imperial and other traditional measurement systems created, and why do they contain so many patterns involving 3, 6, and 9? The imperial system was originally based on the human body. For example, a mile came from 1,000 Roman paces and an inch was roughly the width of a man's thumb. These units were used and loosely standardized by the Romans, then further formalized in England, eventually becoming the British imperial system in 1824. While not part of the imperial system itself, older cultures influenced the mathematical mindset that helped shape it. For example, the Babylonians, using a base 16 number system, divided the circle into 360 degrees, a number that was both astronomically symbolic, approximating the number of days in a year, and mathematically convenient, 360 having 24 divisors. Additionally, the ancient Egyptians emphasized 3 and 6 in their use of unit fractions, reflecting both mathematical efficiency and symbolic preference. These ancient preferences helped embed patterns involving 3, 6, and 9 into Western systems, echoes of which can still be found in aspects of the imperial system. Imperial and other traditional measurement systems preserve the symbolic and mathematical heritage of ancient civilizations, cultures that valued numbers like 3, 6, and 9 not only for their divisibility and usefulness in human-centered measurements, but also for their deeper spiritual meaning. In contrast, the metric system emphasizes base 10 simplicity and universal standardization. Older systems reflect a legacy of sacred patterns, historical intuition, and body-based design. This could explain why many measurements in the imperial and other traditional measurement systems contain patterns involving 3, 6, or 9. However, rather than diminishing their significance, the fact that ancient cultures built these systems around such numbers actually reinforces the importance they placed on their unique mathematical and symbolic properties. Now it's time to wrap everything up with my final verdict. Given everything we've explored, I think Nikola Tesla was right in that he was onto something when he said that 3, 6, and 9 are the keys to the universe. Even though there are many explanations for why these numbers pop up, the fact that so many ancient cultures place value and emphasis on them shouldn't be ignored. Trying to debunk these claims actually solidified my opinion about their significance. You can always find examples of numbers or values that do or don't connect to 3, 6, or 9, but the ones that do are surprisingly abundant. Yes, selective reasoning is part of it, but the patterns weren't hard to find. In fact, many random things I looked up to disprove the idea ended up supporting it, like how the Earth's axis is tilted at 23.4 degrees, which has a digital root of 9. Even while I was downloading an image for an unrelated project, I noticed all 5 available sizes were divisible by 3 and 6, and one of them, 144, was also divisible by 9, which wasn't something I was even looking for. Before starting this project, it used to annoy me that the US was one of the few countries, along with Liberia and Myanmar, that still use the imperial system. I hated that we always try to be different from the rest of the world, and I used to want us to adopt the metric system. But now, I'm actually glad we use it. I feel it's important to preserve systems like this. They carry ancient traditions, intuitive design, and a mathematical language that's deeply tied to numbers like 3, 6, and 9. I started this project searching for meaning behind these numbers, and honestly to see if I could debunk the whole theory. But now, I'm even more convinced that these numbers are sacred, and that they might be pointing to something bigger. Does that mean they're codes to a simulation, the keys to the universe, or maybe nothing at all? I'm curious what you all think. Do you believe that these numbers are sacred too? What do you think this implies about our world and the universe? Please let me know in the comments, and thank you so much for watching this through.